All right, just going over the quiz review. Okay, so if you guys have any questions, you can watch the video here. Okay, so first things first is that when we look at this first question here, where we're going to use geometric vectors to find the resultant, we need to go ahead and first find the components of each. Okay, so remember, to get my components, I go from initial to terminal here. Okay, and so I'm going to go over, looks like 1 and then down 1, 2, 3. So over 1, down 1, 2, 3. And so that means my components for vector A are going to be 1, negative 3. Okay, again, initial point up here, terminal point down here by the arrow. To find the components for B, I'm going to go over 1, 2, down 1, 2. And so my components for vector B are going to be, gosh man, I can't write it. Okay, are going to be negative 2, negative 2. And then now for C, C is very basic. That's just a vertical. It just says vertical components. So again, start here, down at your initial point. Go to your terminal point. Okay, and you're going to go up 1, 2, 3, 4. You do not go left or right at all. So you're going to 0 for your horizontal component. Vertical component is going to be 4. Okay, and so it wants us to do 2A minus B. So think about it this way, right? I need to write A twice. So A goes over right, down 3. So A is going southeast. And then we're doing opposite B, which would be, B would normally be southwest, but since it's opposite, what's opposite of southwest, we're going to go northeast. So I think I'm going to start like up here with A. Okay, so here's my initial point. Label that IP, because that's going to help me remember resultant. And now what am I going to do? To draw A, I'm going to go right 1, down 3. So down, over 1, down 3, 1, 2, 3. Draw a point there, and there you go. There's my first A. Okay, and so I'm going to label that real quick. A. Okay, so I label that A, and then from the end of that first A, I'm going to draw another A again. So I'm going to go over right, down 1, 2, 3. Plot a point there. Okay, and then connect the terminal point of that first A to the terminal point of the second A. Alright, and so I'm going to write that as an A there. And then now we're doing opposite of B, right? So opposite of B. So normally B would be going southwest. How do I know opposite? Because the negative sign in front of the B. So normally B would be going southwest, but because we're doing opposite, we're now going to go right 1, 2, up 1, 2. Plot a point there. Connect the 2 points, and now I label this my terminal point because that is the terminal point of the last vector being drawn. We label this here as a negative B. And so there you go. So guys, that's how I want you to label it on the quiz, okay? Need you to label. Alright? And so now what I'm going to do is how do I draw my resultant? Well, my resultant comes from the initial point of from the first vector to the terminal point of the second vector. I'm going to shade that in kind of heavy for you guys. So you can see there's my resultant. It's the real shaded thick line there. And now we need to find its components because it wants me to find the magnitude. So the components are going to be right 1, 2, 3, 4, down 1, 2, 3, 4. Okay, and so the components for U are going to be over 4, down 4. So to find the magnitude, remember we take the two components, 4 squared plus a negative 4 squared. You square both of them. Again, because that's a negative 4, make sure you put in parentheses when you plug it into your calculator. If you don't, it will give you a negative number when you square it, which we know that's not true. Any number raised to the second power is always going to be positive. So when you square both those, you take the square root, you end up left with the square root of 32, which I want you to simplify. breaks down to be 4 root 2, and there you go, there's your magnitude. Okay. All right, number 2 here, we've got negative 1/2 vector C plus vector B minus A. So when we look first at negative 1/2 C, okay, so first off, opposite of going north is going to be south, so we know we're going down, and then we're doing half of that. So normally we go up 4, but this time we're going to go down 2. I'm going to start up here, I think, in the top right, because then with B, I'm going to go southwest, and then I'm doing opposite A, which then would take me what? What is opposite of A? A is southeast, so that's going to give you northwest. Okay, so I'm going to start up here. Again, guys, the reason why I know this is because I've done this a lot, okay? I mean, this takes practice. You may mess up and have to erase and start somewhere again. So that's my initial point, and it's going to be opposite, so I'm going south, and then half of 4. So I'm going to go 1, 2, plot a point there, and I label this negative 1/2 C. Okay, now we're going original B, because it just says plus vector B. So B was originally left 2, down 2, 1, 2. So I went left 2, down 2. Plot a point there. Connect the 2 points, and that's going to be B. Okay. And then last one, it says negative A, so opposite A. So normally for A, we would go right 1. We go right 1, down 3. But it wants us to do the opposite because of that negative sign. So I'm going to go left 1, and then I'm going to go up 3. 1, 2, 3. Plot a point there and connect it. So left 1, up 3 because opposite A. I'm going to write TP there because that is the last point of the last vector being drawn. And now to find my resultant, I'm just going to connect the IP and the TP. Again, I'll shade this in really thick for you guys so you can see where my resultant is. Okay, and remember, to find the components, we go from the IP to the TP. So we're going over 1, 2, 3, down 1. Okay, so the components for vector V are left 3, so negative 3, down 1, negative 1. So again, to find your magnitude, you're going to take the square root. Okay, the square root of the components. So in this case, negative 3 squared plus a negative 1 squared, which that just ends up being the square root of 10, and that does not simplify anymore. Okay, that does not simplify anymore, so therefore there is your magnitude. Again, guys, very easy. Okay, very easy if you have your formulas in front of you. Okay, very easy if you have your formulas in front of you. So 3 and 4 says, given the initial terminal points, find the component form. Okay, so recall what our formula was for that, right? It was x2 minus x1, comma y2 minus y1. So I just go ahead, before I start this, guys, I just go ahead and I label. So I just do x1, y1, x2, y2. Okay, and then I go well, we haven't started that problem yet, I'm sorry. So now let's go ahead, let's plug that in to our formula. So we're going to get y2, which is x2, okay, which is 4 minus 3, which is x1, comma y2, which is a negative 7, minus y1. Again, what you guys are noticing is that you're getting 2 negatives here because that minus is from the formula, that negative 1 is from your y1. So 2 negatives equal a plus. Okay, and so our component form now we're just going to simplify. 4 minus 3 is a 1. And then negative 7 plus 1 is going to be a negative 6. So there's your component form. Remember, sum of unit vectors is very easy. You just put an I and j next to it. So it's going to be 1i minus 6j. And there you go. So that's your component. That's component form. That's sum of unit vectors. Okay, same thing here. We're going to do the exact same thing. We're going to label x1, y1, x2, y2. How do you know what is the initial, what's the terminal? It's just how the letters are listed in a row, right? P, Q, so P is going to be our initial point, Q is going to be our terminal point. Okay, so let's go ahead and plug it into our formula here. Okay, we're going to get x2, so we're going to get negative 2 minus 1, and then we're going to get negative 9 minus 12. And so that's going to give me then this is going to give me a component form of negative 3 minus 21. So sum of unit vectors is very easy there. We're just going to put 9j next to this. We're going to get negative 3i. Don't forget your line with your half arrow above the I. Minus 21j. And there you go. That's your sum of unit vectors. Okay? So let's go ahead. We're going to scroll up some here. Okay, so it says if x and y, so we're given the initial and terminal for a vector here. We want to know is xy the same as yx. Okay, so if I'm doing xy here, okay, let's go ahead. We're doing pretty much the same thing we did number 3. We're trying to find the component form. So we're going to go x1, y1, x2, y2, because x is first. So we'll call x1, y1 there for that first ordered pair, and then the y value will be x2, y2. So let's go ahead and plug that in. And so when we do that, we're going to get x2, which is a negative 8, minus x1, which is 10, comma y2, which is a 2, minus a negative 8. And so when you do that, that's going to give you negative 18. 2 minus 8, that's 2 plus 8, 10. Okay, so the component form, if we were looking at it from xy, is going to be negative 18, 10. Now let's find yx. So yx, we're going to change how we label it. Since y is coming first, this is now going to be my x1, y1. Okay, and then my x is going to be my x2, y2. So now let's go ahead and let's find the component form for yx. So we're doing x2 minus x1, so that's going to give you 10 minus a negative 8. And then we're doing y2 minus y1, and so that's going to give you a negative 8 minus 2. Okay? And so now let's go ahead and simplify. 10 minus 8, that's going to give you 10 plus 8, which is going to give you 18. And then negative 8 minus 2, negative 10. And so there you go. So yx is 18 comma negative 10. So it says, what is the relationship? What is the relationship? We'll look at them. Okay? In the first vector there, xy, you had negative 18. The second one, you have positive 18. So really just the signs are changing. Okay? When you look at the when you look at the vertical component, same thing. All the thing that's happening is the signs are changing. And so what we know from that is that they are opposite vectors. Okay, so that's what that means. All right. So now on 6 through 10, we're going to use some of these vectors here. Again, probably what I would do is, first off, is whenever you're given a sum of unit vectors, just go ahead and write the components for it so you're not confused. So 8i minus 12j is just going to be 8. Negative 12, you're just dropping the I and the j to write the component form. We're given the component form for a and b, and so it's just a lot easier that way. Okay, so it says, find an ordered pair to represent d. Okay, so we're trying to find a new vector, d, by adding these two vectors here. So we're going to get, it's going to look like this. So we're going to do negative 2 times the components of a, which is 3 and 2, plus 1/2 times the components of c, which are 8 and negative 12. So then that's going to give you this. Remember, you got to distribute that -2 to both terms there. So you're going to get a -6, -4, plus you're distributing that 1/2 to both terms in vector C there. And so that's going to give you then 4 and -6. Now that we have simplified, we're going to go ahead and take the like components. So you're going to get -6 plus 4, and then -4 minus 6. And when you now when you simplify those, this is going to be your component form. It's going to be -2, -10. Okay, number 7 here, we want to find an ordered pair to represent E if we're doing A minus B. Okay, so it's just going to look like this. So your components for A are just 3, 2, minus B. The components for B are -4, 4. Okay, so for our next step here, we're going to go ahead. We got to distribute this minus sign to both terms in the component form of B. And when I do that, I'm going to have this. I'm going to have 3, 2, change to a plus because that minus sign went through to the second vector component form. And so you're going to get this. You're going to get +4, -4. And so now you're going to go ahead and you're going to combine like components. So we're going to get 3 plus 4. And then your vertical components are 2 minus 4. And so now we're going to go ahead and simplify those. When we do that, you're going to get 7 minus 2. And there you go. There's your component form there. So that was just adding and subtracting multiple vector components. Okay, sorry. I didn't turn that on the back there. All right. So now we are going to go ahead and, sorry about that. It says find the magnitude and direction of each, right? So we're going to need our calculator here. So B, again, go ahead up here. I changed the sum of unit vectors to the component form, just so it's easy, quicker. All right. So go ahead for vector B, magnitude again. It's just the square root of the component. So we're going to go -4 squared plus 4 squared, which gives you the square root of 32, which then equals 4 root 2. And so that's our magnitude. Okay. Our direction, all right, again, for direction, do theta equals, you do tan inverse. Tan inverse, you always do the vertical component over the horizontal, so it's 4 over -4. And so I'm going to go ahead and take my calculator here now. Tan inverse, we're going to do 4 over -4. I'm sorry, I don't know why I did that. Close parentheses, and you get -45. Now, what direction am I going in here, right? Like what direction? So when I look at the components for B, that's left and then up, so it's going northwest. Okay, so you're going to take that -45. You are going to quadrant 2 because you're going left 4, up 4, and so you're going to go ahead and add 180 to that because you're trying to get to quadrant 2. And so when you do -45 plus 180, that's going to give you 135. Okay, and so that is the angle, is 135. So 4 root 2 is the magnitude, 135 is the angle. All right, vector C. Okay, we take our component form here, 8 squared plus a -12 squared. This time I'm just going to use my calculator to be quick. So we're going to do square root of 8 squared plus, I don't know why that did an X, I'm sorry. -12 squared. Oh wait, I don't know why, yeah. Sorry, guys. I was doing this close to the right. So close parentheses there. Square it because it's a negative. Hit enter. Okay, and we get 4 root 13 for the magnitude. Okay. So we get the magnitude to be 4 root 13. And then now for direction, same thing here. We're going to go theta. It's always tan inverse. Okay, we're going to go vertical over horizontal as always. And so when I do that, what do I get there? I'm going tan inverse of negative 12 over 8. And that's going to be a negative 56.3. Now I'm trying to get a, it looks like 8 comma negative 12, it looks like quadrant 4, right? Because you're going right and then down. So it's going southeast, that vector is. And so to get a proper angle in quadrant 4, I got to go ahead and add 360. And so when I do negative 56.3 plus 360, I get 303.7 degrees. Okay? Our vectors A and C are orthogonal. How we do that is we do the dot product. Okay, so remember, the dot product is just A1, A2 plus B1, B2. And we kind of label those the same way as like X1, Y1, X2, Y2. Okay, so that would mean then that A times C is going to look like this, right? So we're going to take the horizontal components from A and C and multiply them together. So it's going to be 3 times 8. And then adding plus B1, okay, which is 2. B2, which is a negative 12. And so when you do that, you're going to get this. You're going to get 24 minus 24, which equals 0. Okay? And so, yes, they are orthogonal because the dot product sorry, I don't know why I'm having trouble here, because the dot product got 0. If it doesn't get 0, guys, then they're not orthogonal, okay? And then recall how they are parallel, right? You must be able to take one of the components and multiply them by a scalar to get the second component. Okay. All right. Sketching a bearing. We haven't talked about this too much. Okay, so I'll show you how to do it. I would expect not to have a problem like this on the quiz. But bearings start at the north. Okay, normally we were used to starting here on the positive x-axis and then going, but bearings start at the north. All right, so my initial side is going to start at the north, and then I'm going to go 260 degrees clockwise. 260 degrees clockwise. So this is now 0, 90, 180, 270. So I'm going to start, and then obviously 360 to make it back around. Okay, so we're going to start north, we're going to go close, and then we're going to draw from the origin an angle that looks close to 270 because it wants 260, right? And so how I draw this is I draw my arrow at 260 degrees, and then on that vector, because remember, vector is not only the angle, it's also a unit of measurement, I write 10 mph. So that vector is going, that bearing, okay, sketch of the vector described at 10 miles per hour at a bearing of 260. So that's how we draw bearings. Always start at the north, right? And so you're expected to draw a vector that has direction and measurement. All right? Our formula for finding the component form given the magnitude and direction is this. Sorry, it's not cosine, it's sine. Okay? And that should be an A as well. I'm sorry, guys, struggling a little bit here. I apologize. Okay, and so now let's go ahead and fill it in. So we know magnitude. Remember, how do I know that this is the magnitude? Look at your symbol there. It's absolute value. It's not absolute value, but it has the two lines like the absolute value with the vector squished in between. And so our formula is going to look like this. And this is what we're going to plug into our calculator. So it's going to be 12 cosine 225 degrees, 12 sine 225 degrees, and then closed arrow there. Again, this is going in our calculator. Make sure your calculator is in degrees. Go to mode. Make sure degree is highlighted. We do not need radians at all, this whole entire unit. And so we're going to get 12. Okay, that's going to be 12 cosine 225. Hit enter. Okay, we want the exact value. I do not want decimals. And so then that's going to give me negative 6 root 2. And then we're going to do 12 sine 225, and we get a negative 6 root 2. And there you go. There is your component form for 12. Okay, 13. Same thing here. We're going to have 7 cosine 270 degrees, because 7 is the magnitude, 270 degrees is the direction. Okay, and then comma 7 sine 200, not 20, 70. Geez, wow, I'm really sorry, guys. I'm not gonna lie. I guess I'm tired because I stayed up and watched the college football game last night. I'm really sorry about that. And I've been working a ton since about 7:30 this morning. No excuses though. No excuses. So I apologize about that. So 7 cosine 270. So we're gonna do that in the calculator. 7 cosine 270. Enter, and that gives me 0. And then we're going to go 7 sine 270. And that's going to give you negative 7. Okay, and there you go. So there's your component forms given the magnitude and the direction. Okay, so now it wants us to find the angle in between. So there's 3 things we have to do. 1, we have to find the dot product. So it's our first step, and then find the magnitude of both, and then plug it into our formula. Okay, so it's going to look like this. So we need to do the dot product of A times B. Again, that comes from, you're going to pretty much multiply the like components. So we're going to have this. So it's going to be 9 times a negative 1 plus a negative 4 times a negative 2. And so that is going to equal, okay, negative 9 plus a negative 4 times negative 2, so plus 8. And so then your dot product is going to be just a negative 1. Okay, next thing is magnitude of A. So again, how do we find the magnitude? We take the components of A, square them, add them together, and then take the square root. Just to be quick here, I'm going to use my calculator, so I'm going to go square root 9 squared plus parentheses negative 4 squared. I hit enter and I get the square root of 97. Okay, which I'm pretty sure, yeah, that doesn't simplify, otherwise it would have simplified for us. So square root of 97 there. Okay, and then I'm going to do the same thing, magnitude of b. Okay, so again, square root. We need to take the components, square both of them. Okay, take the components, square both of them, add them together, and then take the square root. And when I do that, that's going to give me the square root of 5. Alright, and so now what we're going to do is we're going to go ahead and just plug it in our formula because we have every part. So we're doing, it's always cosine inverse, okay, of your dot product in the top, so negative 1, all over, okay, the magnitude of u, well in this case it's the magnitude of a, sorry. So we're going to put that in parentheses, square root of 97, times the magnitude of b in the denominator, which is going to be in square root of 5. Plug that all into our calculator here now. So you're going to go cosine inverse, fraction button, negative 1, open parentheses, square root, 97, close parentheses, open parentheses, second square root button, well, x squared button, 5, take that out of the parentheses, close the parentheses, and I'm going to hit enter here. And you are going to get 92.6 degrees. And that is going to be your answer. Okay, last but not least here, 15. Again, we're asked to find the angle between, so we have to do the dot product for C and D. So we're going to have C times D. So, again, take the like components and multiply them together. So you're going to get, the dot product is going to be 2 times 3, because those are both your horizontal components, plus multiplying your vertical components, negative 2 times 8. And so then that's going to give you something like this, where you're going to have now 6 minus 16, which then that equals negative 10. So our dot product is negative 10. Okay, now we must find the magnitude for both. Okay, and so the magnitude for C is going to be, again, taking the components of C, squaring them, okay, adding them together, and then taking the square root. And so that's going to give you 4 plus 4, which is 8, so that gives you the square root of 8, which then breaks down to be 2 root 2. Last but not least here, we need to do the magnitude of D. So again, we're going to take the components of D, 3, square it, 8, square it, add them together, and then take the square root. Can't think of that one off the top of my head, so I'm going to go ahead and be quick here with the calculator. 3 squared plus 8 squared. Hit enter, and that's going to give you the square root of 73. And now once we've done those 3 parts, we can go ahead and just plug it into our formula. So it's going to be cosine inverse, dot product always in the numerator, so negative 10 over parentheses, open parentheses, 2 root 2, close parentheses, open parentheses, root 73, close parentheses, and then we will get our answer. So let's go ahead and plug that into the calculator. And so we're going to get cosine inverse, fraction button, negative 10, open parentheses 2, second, x squared for the root, put 2 underneath. Make sure you're outside when you close parentheses, not under the radical sign. Open parentheses, second, x squared, type the 73 in, Make sure you're outside of the radical sign again, like the R there, and then we got to totally close the whole thing. Hit enter, and there we go. So we get 114.4 degrees. There you go. So guys, that wraps up the quiz review. All right. Yes, a little lengthy, but like I said, if you can do the whole quiz review, then the quiz will be easy for Thursday. All right. So please make sure you spend time going over this. Thanks, guys, and I'll see you in class on Wednesday. Peace.